Good morning, Geometry iPad Initiative students. This is section 5.1, perpendicular and angle bisectors. Hopefully you're having a wonderful start to this new semester. This second time recording this, so hopefully it goes a little bit better than the first one. Hopefully you can hear me on this one, and we'll get to rolling. Make sure you're paying attention for that secret word. 2 points for the first person to send it to me. In your notes, make sure that you got the title. And number 5, you need to answer that in your notes and send it to me. So this should be the first points of the new semester here. Alright, let's get to rolling on this. Perpendicular bisector is a segment ray or line that is perpendicular to a segment at its midpoint. So we got a drawing that goes along with that a little bit right here. Notice that the endpoints are A and B. So P must be the midpoint. So it cuts it in half, creating these two segments that would be congruent, AP and BP. And then the angle form for perpendicular would be a right angle. So this would be the perpendicular bisector of segment AB. We have a theorem that goes along with that says, well, that is the perpendicular bisector theorem. It says in a plane, if 2 points are on the perpendicular bisector of a segment, then they are equidistant from the endpoints of the segment. So notice that with these markings here of congruent and the right angle, that CP would be the perpendicular bisector of segment AB. So what does that tell us? That tells us that if if C here would be on that perpendicular bisector, then it's going to be the same distance from CA to CB. Those two things would be the same distance also. Same as we went down here, then this length would be the same as that length. So any point that we choose along that perpendicular bisector is going to be the same distance from that point to A as it is to B. Now the converse of that, remember the converse just flips the hypothesis and the conclusion. So this one says in a plane, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So D here, notice that it's equal distance from A and B, so that would mean that D would have to be on the perpendicular bisector. Alright, so those are the markings that we'd have to have, and then say it was on the perpendicular bisector for that particular situation. Alright, I think we've got an example here that we need to work. It says that BD is a perpendicular bisector of AC. Find AD. So a few things that we can mark. If BD is the perpendicular bisector, that means that that's going to be congruent with that. That's going to mean that that's the right angle, and that's going to mean if D is on the perpendicular bisector, that this length would equal that length. So to work this problem, all we have to do is set the 3x plus 14 equal to the 5x, and then we must solve that. So I'm going to subtract the 3x from both sides, and that's going to give me a 2x is equal to a 14. And then when we divide by 2, looks like x is going to be equal to 7. So if we want to know a length of AD, then we need to plug that back in for x. So 7 times 5 would be 35. Also, without plugging it back into this top one, CD, I would know that it would equal 35 also. Alright, in the diagram, WX is the perpendicular bisector of YZ. So YZ, let's see, those two are going to be congruent. What is the segment lengths in the diagram that are equal? Well, I think we could state that since these are 25, we know that what? YV would have to be equal to ZV. And then, let's see, we know that YX would have to equal XZ. And you would have to know that WY would equal WZ also. Okay. about it. Alright, is V on the WX, which is the perpendicular bisector. So let's see, if it's the same distance from that point to Y as it is to Z, then by the converse of the perpendicular bisectors theorem, we would have to say that yes, it would be on WX. It would be linear with that line. Let's move on. Regular geometry class would be doing those at this time. iPad initiative, we're going to move on here. So angle bisectors now is a ray, line, or segment that divides an angle into two congruent adjacent segments. And then the distance from a point to a line is the length of the perpendicular segment from the point to the line. So right here I think we have a drawing that goes along with this a little bit. So notice that PS is a ray that bisects the angle, so it would be an angle bisector, and then it's showing that the distance from S to R is this blue line. From S to Q is this blue line. Notice that we got to define that distance as something, because all these lines that we could draw from S over to that side of the angle would be a different length. So we always go with the shortest length, which is the perpendicular segment from that point to the side. Alright, got a couple of theorems that go along with this. The first one is the angle bisector theorem. It says if a point is on the bisector of an angle, then it is equidistant from the two sides of an angle. So notice that we got the markings to mark AD as a angle bisector, and then D, we'd have to know that this distance was equal to this distance if it's on the perpendicular bisector. Okay, and then it says if a point is on the interior of an angle and is equidistant from the sides of an angle, then it lies on the bisector of the angle. So notice that this distance is equal to this distance. It is the perpendicular distance between D and B and D and C. So therefore D would have to lie on the angle bisector by the converse of the angle bisector theorem. So what type of work are we going to do with this, it looks like? Find the measure of angle GFJ, so this one right here. Well, to get there, notice that J would have to be on the perpendicular bisector because we've got 7 and 7 right here, so if these are congruent, then that would tell us that it lies on the angle bisector. Well, with that said, this would have to be congruent with this little angle right here, and if that's 42, then that would mean this top one would have to be 42 also. Very good job. By the way, the secret word today is pie. No flavor, just pie. Let's see, example 2 says find the value of P that would make P lie on the bisector of angle A. So P is right here. For it to be on the bisector, that means that the two blue lines would have to be equal. So I'm going to put x plus 3 equals 2x minus 1. Got to bring my x's to the same side, so I'm going to go ahead and just subtract the x, which will give me just 1x. And then I've got to add the 1, which would give me 4 for x. So each one of these lengths would have to be what? 7. And yes, then if x was 4, then they would be equidistant, making a P on the angle bisector. Alright, moving on here. Find the value of x on this one. Well, again, we got a point right here that's on the angle bisector. That would have to make these two congruent right here. So I'd stick 3x plus 5 equals 4x minus 6. And then if I subtracted the 3x's, I would get just x here. And then add my 6. And x would have to equal 11. So I've got to take that and I've got to plug it back in for my x to find what each angle was. I guess I don't have to because I'm supposed to just find x. But each angle looks to be 33 plus 5 would be 38. Top one's that, the bottom one has to be that. Alright, moving on here. Regular class would be doing that. We'll move on, and we've got kind of a tough little problem right here. I think for this problem we might want to pull up the old graph and put it in here. Just like so. And it says write an equation in slope-intercept form for the perpendicular bisectors of a segment with the given endpoints. So these are the two endpoints. We want to just start by graphing those. So 1, 2, 3, 4, 5, up 1, 2, 3, 4, and then n is at 1, -2. So these are our two endpoints, and we're supposed to come up with that segment bisector, the equation of that line. So fairly difficult. We could try and count towards the middle here, but we have the for the midpoint formula. We also can just add the two x's together. So -5 plus 1 divided by 2 is the formula, and then add the two y's together and divide that by 2 also. So we got what? -4 divided by 2 is -2, and then we got 4 plus a -2 is a 2 divided by 2 is a 1. So we now know that this point has to lie on the line. Well, the next thing we need to know is slope of the line, because if you remember on perpendicular it's opposite reciprocals. So I need to change the sign and I need to flip it over. But first let's find the slope of this line, which would be, let's see, this would be my x1, my y1, my x2, and my y2. So I'd have a -2 minus a 4 over a 1 minus a -5, so it's going to turn into a +5. So that's going to be a -6 over 6, which is -1. So now I must take the slope and the point and figure out from those what the equation is. So let's clear us a little bit of room over here. We're going to need it. And let's go back and choose a little green here. So we're going to go to y equals mx plus b. And what I'm going to be solving this for is my b, and I'll have the equation. So I'm going to plug in my y is 1. I'm going to plug in my slope is -1. And then I'm going to plug in my x value, which is -2. So negative times negative is going to be a positive. Subtract the 2, looks to be a -1 for my b. So now we must just rewrite the equation real quick. So it will be y equals -1 x minus 1. Alright, a little tough there. Hopefully you'll pay attention. Maybe rewind that and watch it one more time. There's the regular classes homework. iPad, yours will be on the, there's the up one, down ones, and the boxes real quick. Good luck. Woohoo! Yes, hope that's what you wanted. Excellent job. And this is Mr. Lane signing off from OHS High School. We'll catch you on the flip side. Good night.